In this video we're going to look at electrochemistry, and we're specifically going to look at the experiment of electrolysis of potassium iodide with inert electrodes. So our learning intentions is to discuss electrolysis of aqueous potassium iodide with inert electrodes. So in this experiment we are looking at an electric current passing through potassium iodide using inert electrodes. And what makes this electrolysis experiment different to the ones that we've completed already is that in this electrolysis experiment a gas is given off at only one electron. So this is always carried out in your inverted test tube voltameter. We're using inert electrodes again, so these electrodes will be platinum electrodes and they will be connected to the positive and negative ends of the battery respectively. So our solution that we have here is a dilute potassium iodide solution, and we've added phenolphthalein to this solution. And the function of the phenolphthalein is to allow us to see a colour change so that we know that our reaction is occurring. So at the start of the experiment, the solution will be completely colourless when the phenolphthalein is added. As electrolysis progresses, a brown colour will develop at the positive electrode, at the anode, and this brown colour is due to the formation of iodine. And this is because the negative iodide ions in the potassium iodide solution are attracted to this positive electrode, and each of these iodide ions will lose an electron to form an iodine atom, which gives us our brown colour. Meanwhile, at the negative electrode, which is the cathode, a pink colour will be observed, and this is because we are forming hydrogen gas, and the phenolphthalein turns pink, which implies that the solution is turning alkaline. So the OH- ions that are formed give us our pink colour. So to put this into words for you then, at the positive electrode, which is our anode, we have oxidation occurring. And this is because the negative iodide ions that are present in our potassium iodide solution are attracted to the positive electrode. And this attraction causes iodine to be produced, and this is because each of the iodides loses an electron each, so 2 electrons in total are lost. So that gives us our brown colour at our anode from the formation of the iodine. Now if we were to use a different indicator, for example starch, what we would obtain is we would obtain a blue-black colour during our electrolysis. So now let's look at what happens at the negative electrode, which is the cathode. Reduction occurs at the cathode, and the first obvious thing that we would observe is a pink colour will be obtained at the liquid in the cathode, and this is due to the formation of hydroxide ions. And we know that they're hydroxide ions because phenolphthalein turns pink in a basic solution. Now you may wonder, where did these hydroxide ions come from? So they came from the water being forced to accept electrons, and this causes the water to become unstable and to split. So as we can see here in our balanced equation, the water is forced to accept the electrons and it causes it to split into hydrogen gas and our OH- ions. So the OH- ions are explained with the phenolphthalein, and the hydrogen gas is collected in our inverted test tube. So we could check that this is hydrogen gas to make sure that it burns with a pop. A common question that can come up with this electrolysis experiment in an exam is, why do the potassium ions from the Ki not take part in the reaction? And this is because potassium metal is such a reactive metal that it is far more stable in its +1 oxidation state. So basically, adding an electron would require far too much energy, so the potassium ion plays no part in the reaction, and it is therefore called a spectator ion. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.